Hello. Today, we're going to make the game of Snake. If you know what this indestructible phone is, then you probably know what the game of Snake is. But just in case you don't, let me give you a quick rundown in like 15 seconds. Snake is a game where you're constantly moving around in the game area and eating food, because you're hungry, I guess. When you eat food, you grow immediately. I guess there's a lot of protein or something in it. But when you do, you gain a point. But here's the trick. As you move around the game area, if you run into yourself, like your own body, or you hit the edge of the game area, you lose the game. That's basically it. Snake. Alright, so I've got a number of files here for kind of examples for how we're going to make Snake, just so we can kind of go through it iteratively. So we're going to start simple, and we're going to keep building on top of it. So our first file here is we're going to be importing PyGame, and we're going to import these other things, but more so that because we need them later. So what we do here is we initialize PyGame, which is just the module we are using, the pip module. Obviously, you should pip install PyGame if you haven't done this, if you're going to follow along. Next, we make the screen width and height, and we just set those for variables so we can reference them later. Then we're going to make a bunch of colors. These are RGB values, so R, red, green, blue. If you want to learn more about RGB and hex and how that works, check out this video up here. And then we create a screen. The screen is basically like the canvas for the game. So the way this works is we do pygame.display.setMode, and then we set the screen width and height within a tuple. A tuple, if you remember, is basically like an array, but it's got it's got parentheses rather than square brackets. Perfect. And then we set pygame.display.setCaption to Jake the Snake, because that's what I'm going to call my snake game. And then we set while true. This is basically the game loop to be pygame.display.update. So let's go ahead and run this. And we can see this is our game. You can see we have a little spinning wheel because it's just constantly updating and not really doing anything. But we have a pop-up, and it is kind of trying to do something. So that's progress. All right, let's go on to version 2. Here, we're going to add movement to the game. We're going to actually render something and move it around. So you'll notice that basically a lot of this stuff is the same. We're going to still set the screen dimensions, still creating our screen game, but now we're going to make a snake. So we have the snake block, which is going to be equal to 20. This is 20 pixels, so 20 pixels wide and high. So basically just a square. Then we're going to set the snake speed to be 15, which means you'll move around at a rate of 15, 15 iterations per second. We'll kind of talk about that later. Then the font, we're going to set font here. We don't really need font in this right now, but we're going to just set it up so that we can use it later. So we're going to set the font to system font. We're going to just say none, so just pick the default. We're going to set it to a size of 36. And then we're going to get the clock, which is how we're going to use the clock to determine the snake speed. All right, great. And now you can see we have a lot more. We have a game loop and a lot more code. So let's go over this first. So first off, we called the game loop at the end of this. And within here, we have two booleans. We have game over and game close. So if the game is over, we're going to exit our while loop and just quit the game. And if the game is closed, meaning that we've pressed a button or clicked something else, then we are going to fill the screen to be black, and we're going to quit the game and exit. Now, this initial snake position is we're going to set to the X and the Y. So remember, if you remember math, X is the horizontal and Y is the vertical. So this is basically the center of the X, so the center going this way, and then the center of the Y going this way, so basically in the center of the screen. And then we create some variables called x1 change and y1 change. And these are basically just how much are we changing for our snake, how much are we changing in each direction of the X or the Y. All right, so we've kind of talked about this game close already. Let's go over what happens when we're not closing the game, the more exciting part. So first off, PyGame has an event queue. Basically, an event queue just means that when any types of event happen, the PyGame library will get all those events. Those are like key presses, clicks, things like that. And it will add them to this event queue. So a list, basically a list of events that have happened since the last time we've checked this list. This list, you can just peek. There's a number of things you can do in order to read from it. But basically what we're going to be doing here is we're going to be getting each value from that list and then checking what it's doing. So for instance, if we get this quit value, then we're going to set game over to be equal to true, and we're going to exit the game. If the event is a type of key down event, then we're going to get which key was it. And in this case, PyGame has some a nice library, which is built up with specific keys. So we can just do pygame.key_left, which is the left arrow on the keyboard. Same with right, up, down. Now, if the left key was pressed, we're going to set the x1's change to be negative the snake block. So this means that we're moving negative however large the snake is in the x direction. So negative x, which would just mean left. And then we're setting y to be 0 because we don't want to move up and left. We want to just move left, right, up, or down. For the right, we just set it to the positive snake block. So we're going to move right, or positive change in the x. So now we have our changes, but first we're going to do something here. So let's check if the snake has hit the edge of the screen. So we're going to see if the x1, because remember this is the actual position of the snake's head. If this is greater than or equal to the screen width, or it's less than 0, because the screen width less than 0 would be out of the screen as well, or the y1, so the y coordinate of the snake is greater than or equal to the screen height, or it's basically off the screen in the other direction, we're going to set the game close to be true. So we're going to be finished with the game. Then we're going to add the x1 changes and the y1 changes to y1 and x1, because basically that's the new coordinate now that the snake head should be at. Then we're going to fill the screen to be black because the background for the game is going to be black. And we're going to draw on the screen a rectangle with white, which is going to be our snake, at the coordinates of x1, y1, which is what we've defined here. And the width and the height of the snake are just going to be the snake block, because that's what we've defined for the size of the snake. Then we're going to call pygame.display.update, which means it's going to re-render and redraw the screen. And then we have clock.tick snake speed. This basically is how many frames per second would you like the game to render? How many times do we want this loop to be able to run within a given second? So in this case, it's going to run up to 15 times because this is our snake speed. Fantastic. And then again, if we finish this loop, if we get out of this loop, we're going to see pygame.quit and quit. All right, let's run this and see what happens. So if you notice, if I don't press anything, I haven't actually pressed a key down, so the x1 change and the y1 change haven't been set yet. But if I press left, then we start moving left, up, right, down, etc. If I run into the edge, you can see that the game closes because we hit this condition and, well, the game is over. Let's add some more functionality to it. So for this case, we have a case where we're going to add an end screen. So we're going to basically show you the number of points potentially that you have and some things like that. So basically everything up until this point is the exact same, but we've added this message function. Oh, look at that. How did I get there? You know, if you want to take the time right now to consider subscribing, that comment seems to be misplaced, but probably a good suggestion. Why did I do that? All right. So this message function is basically where we define a text variable, and we're going to use the font that we defined previously to render a message, whatever the message is that we pass in, with the specific color. Now, you might notice that we're using this screen.blit after. So the reason we're doing this, and we don't do this when we draw the snake, is because what we return for render is a type surface. And surface is basically the same as a screen to some extent. I don't know the full intricacies of that, but I believe that's the case. So basically what Blit is doing is it's adding the rendered surface to the screen. Technically, I guess the screen isn't a surface, but let me just see here. Does this return surface? It does not. It returns the display. So my apologies. But basically what we're doing is we're adding a surface. So like you can think of it like a full surface, like a full drawing, but only where the text is entered and everything else has like nothing there. And we're drawing that on top of our screen. And the text is that surface, and then we're saying where do we want to draw it. So in this case, we're going to set it to the screen. The x coordinate is going to be the screen width minus the text.get width. So this is basically the full screen width minus some part of the text, and then we're going to divide that by 2 to get the center of the screen. And then we're going to just do the screen height divided by 2. So that's way easier. Okay, fantastic. So the rest of this hasn't changed too much, although we will notice that we now have length of snake. This is initially being set to 1. And then when the game is closed, we're going to, you see now this is a while loop rather than an if statement. But while the game is closed, we're going to fill the screen to black. We're going to now show this message where we show the string of the length of the snake, and we're saying that's your points. And then you can press Q to quit or C to play again. And we're going to render this in red. And then we're going to update the screen, so this is all drawn again. And because this is in a while loop, all of this will run, and we're not going to actually run the game logic. But we are going to listen for some events. So if you press the quit, basically quit is like clicking X on the game. But if the event is a key down press and it is Q, then we're going to just set the game over to true and game close to false. Game closes this, and game over just means that we're going to exit this. And then in the event where we press C, we're just going to run the game loop again. Now, technically, this isn't the best possible thing we can do. Technically, we could just set game close to false here, but this is a simple way of doing it as well. The reason this isn't super ideal is because if you continually press C eventually, you could run into an out of memory error. That's because this is going to be calling itself, which is recursion. And if you want to learn more about recursion, check out this video up here. I have a video on it and why it's actually not that scary and can be very powerful. All right, so the rest of this is the same. We are doing everything the exact same. Okay, so let's run this and see what happens. So we move around as our snake, and we hit the edge, and there we go. We get Q to quit, C to play again, and we had 1 point, which is wrong, but whatever. If we press C, we can see that it re-renders, and we can kind of move around again. I can move left and right because technically I don't hit myself then, but that's fine. We haven't added any logic for that anyways. And I hit the end and I press Q and the game closes. Fantastic. All right, let's move on to 4. In snake 4, we're actually going to be adding food. So something that the snake can eat and we can gain more points, or eventually we'll gain more points. We're not actually adding that into this version. All right, so all of this is the same. Still have the message, still have our length of snake, but now we're going to generate food. Now we're actually going to use this random value here. So what we're doing here is we have food X and food Y. I'm going to change this. I think later in later versions I have this set to a capital X and capital Y, but whatever. For now it's little y and little x. Here we're basically going to generate a random range from 0 to the screen width minus a snake block, because we don't want it to be on the very edge and potentially fall off. And then we're going to divide it by a snake block. And then we're going to round everything and multiply it by a snake block. All right, and then for food Y, we are basically doing the exact same thing. So we're generating an X and a Y coordinate, and there we go. Now, the rest of this, I believe, is the exact same. And the only thing that's different here is that when we draw our snake, we're also going to draw a food. And that is it. So now let's render. And there we go. There's our food. If we run into it, nothing happens. But it works. We now have food. Now our snake can eat because it is a hungry snake. All right, moving on to 5. Now we're going to add point increments. So when we eat our food, we get a point. And we're also going to show the score for the game. So nothing is different from the first bit, although we've now added a point text. So this is doing basically the same thing that message is doing, except it's just going to add the points, whatever the points were provided for as an integer. We're converting it to a string, and we're still using the color. And then we're going to set it to the 5, 5. So basically the top left of the screen. All right, all of this is the exact same. So we still are drawing our food. So then we have point text where we show the length of this, where we have the length of the snake as the points, and we're rendering that in red. And then here we check if the x1's food, so if the head of the snake is equal to the food's x position, and the y of the head of the snake is equal to the food's y position, then we're going to regenerate the food's x and y, and we're going to increase the length of the snake. So this means that that our points are going to be going up. Now, in this initial version, the length of the snake isn't actually going to increase, but we are just increasing this because, again, we want to just do this iteratively to slowly make changes as though we're adding new functionality as we're implementing this from scratch. So let's run this, and we can see that we have 1 point to start. So you got to give you something. And then let's go ahead and hit this, and we now have 2 points. And I'm bad at snake, apparently. Wow, I'm really bad at snake. Come on, Jake. Oh my god, all this pressure. There we go. Okay, I got 4 points. I was put on the spot. I feel terrible. All right, great. So 4 points. That's fantastic. But hey, it works. Okay, let's jump over to Snake 6, our final version. So now we're going to actually make the snake grow, and we're going to change the speed of the game. If you've ever played Snake before, in the past, the real games of Snake, you start out relatively slow. The game moves fairly slow. And as you eat more and more, as your points go up, the game speeds up and becomes faster. So we're going to add some functionality to do that. All right, all of this is the exact same. Now we get to the point where we have snake list equals an array. So this is going to be basically tracking each point for the snake. Now we keep going. All of this is the same. And here we go. Here's where some things are different. So we have a snake head. So we're setting the snake head because we want to track each point of the snake to a new array where the x and the y are set within the array. This is what we're going to refer to later as a segment. Now, we're going to add that to the list. So, for example, in this case, if the snake was at 5, 5, it would be adding 5, 5, or the snake list would be basically this. So it would be an array where the first element is another array where we have 5 and 5, where, again, the head is at 5 for x and y. Now, if the length of the snake list is greater than the length of the snake, so how many points we have, we're going to delete the first element within the list. Basically, the oldest element, because remember when we append things to the list, we add things to the start. Or sorry, we add things to the end, not the start. So why are we doing this? Well, the reason we're doing this is because our list is something that we're going to use to render the snake. But if we continually on each loop where the new snake head value, or this new snake head position is being added to the list, then whatever, assuming we haven't increased and eaten food and we're not a longer snake, then now we have one value within this that is incorrect, right? Because say our snake is of length 2, and we are now adding another snake head to this, and now the snake list is 3 in length. Well, that's wrong because we're only a snake length of 2. So what we need to do is we need to delete the first value, the first element from this list. And basically what that's doing is it's removing the oldest value because, again, we're adding things to the end. So everything that's new is at the end. So we're going to continually do that. But if we've eaten something, then the length of the snake will be increased, which means that now this is fine. It's fine to add something, and now we're not actually going to delete it. So it's not like we want to do this every single time. We only want to do it if the snake list's length is greater than the length of the snake. All right, now we're going to basically check if any part of the snake matches the coordinates for our current head, except for the end of the list, because we've just added the snake head to the end of the list. So this is basically saying for segments within the snake list, except for the last element, if the segment is equal to the snake head, which we have referenced right up here, then we're going to say that the game is closed. So this is covering the case where we've run into ourselves. We want to die when we run into ourselves because that's how the game of snake works. So that's what this is going to be handling. All right, great. So now all we're doing here is we're just going to draw each segment of the snake. So you might notice that we actually start drawing the snake from the tail to the head. It doesn't really matter because from the player's perspective, it's the same thing. We're just drawing something onto the screen and the player's moving things around. But really, in this case, we're drawing from the tail to the head. So we're drawing onto the screen. This is the exact same thing. It's just the X and the Y coordinate are being retrieved from the snake list. All right, food is the same. Now, for speed. Here you can see I'm printing the speed here. And basically, before we just had the speed as snake speed. But, which is a weird sentence. Basically what we, snake speed's so ridiculous. Okay, basically what we have here is we are converting, we're just printing this out so we can see what the snake speed is I'm going to keep laughing at snake speed. I don't know why that's so funny to me. All right, so length of snake is basically how long the snake currently is. And basically when we are defining what our speed is, I'm not going to say snake speed again, we are taking the minimum of the snake speed. I said it. I have to say it. And the maximum. Sorry. Minimum is basically the minimum of this and this. So snake speed is 15, but the maximum is going to be the length of the snake. So it'll start with 1 and 5. Now what this means is that at the very start of the game, this is going to calculate to be equal to 5 because it's going to say the minimum of whatever this is and 15. And in this case, this is the maximum of 1 and 5. So it will set it to 5. So until we hit a length of 6, we're going to be moving at a speed of 5. But as soon as we hit a length of 7, then we're going to be moving at a speed of 7. And it's going to continue to increase. So we're from basically 5 up until 15, we're going to be increasing. And once we hit 15, then this will now be the maximum of, say, 16 or 17 and 5, which would be 16 or 17. And then we're going to take the minimum, which is then going to be the snake speed, because we don't want that to be, we don't want to just continually increase in speed because we want to have some kind of cap. Now, there are certainly some better ways we could do this to make it slightly more gradual or have a higher final speed that is still more gradual, so it's not so intense. But that's it. So let's play our game. So here is our snake. You can see that we're showing the speed of 5 in the console there. And let's move around. You can see we move pretty slow now, which is great. So I can actually hit these things. And we'll go down here. We will go ahead and grab the food because we are a hungry snake. You can see we're still at a speed of 5. And now we're at a speed of 4. And 5. And now we should start speeding up. Very gradual. Oh. 8, 9, 10, 12. Ooh. Okay, I'm feeling it now. I'm feeling pretty good. I just need to get warmed up before. Okay, see, so our speed still is at a max of 15. Okay, I messed it up there. All right, 22 points though, not so bad. If you were actually coding along, let me know what your points are. What your maximum points were, because I don't know. Did you beat 22? I know, pretty impressive score. It's not that impressive. All right, that's it. That's Snake. Now it's just a matter of mastering Snake and getting better than 22. It is actually kind of hard. I don't know if it's just like I'm old now or something, but it's actually a little bit difficult. Thanks for watching. Remember, I'm Jake. You're awesome. And this has been Making Snake with PyGame. Cheers.